All right, so far we got 6 out of the 16 people who have voted. All right, so I'll give you a minute more to work on it, and then we'll do the answer. All right, so let me show the result of the poll. So for this one, it was, oh, here, show result. All right, so if you look at it, we got 2 people who said A, we had 3 people who said B, we have 5 people who said C, and then we have 1 person who said D. So let's actually try to find what the answer is to see who was correct. So for this one's a little bit different because it said we want the first baby to have green eye. So if we want the first baby to have green eye, what's the probability that the first baby have green eyes?
0.06.
Yeah, 0.06. So it's a 0.06. So then we want the second baby not to have green eyes. So what's the probability that the second baby does not have green eyes?
0.94.
Yeah, 0.94. And lastly, we want the third baby to have green eyes. So if the third baby has green eye, what percentage of baby have green eyes?
6.
Yeah. So we're gonna do 0.06 times 0.94 times 0.06. So anybody who said B, they were correct. So B was the correct answer for this one. And that's it for that last problem. Any question for that last problem? All right. So that's it for the multiplication rule for when you have more than 3 events, or sorry, more than 2 events. So if you have 3 events, 4 events, all you have to do is multiply them out. All right, so up next we're going to conditional probability. So for conditional probability, we're going to be using this formula. So I'm going to show you how to read this formula for that way it's nice and easy. So anytime you see the P is just probability. Then if you look at it, you have the A. So it's saying probability of A occurring. And then you see how you have this vertical line right here? So one thing you have to know, that vertical line represents that's the given. So this is information we already know. So we're gonna say probability of A occurring given we already know that B has happened. So that's the way you read that notation. So it's saying probability of A occurring given we already know that B has happened. So whatever come after the vertical line, that's what we already know has occurred. So anything coming after the vertical line, that's the information we already know. So say if I want to find probability, you have an umbrella given it's raining. For this one, the given information is I already know it's raining, and I want to find if you already know it's raining, what's the probability you brought your umbrella? So that's how you read this type of problem. All right. Any question in regard to this last one? Or in regard to the formula? All right. So let's go ahead and let's do this two-way table. So for the two-way table, whenever we're doing a conditional probability, we are trying to see if we have an association. So if you look at part A, it's asking us to see if there's an association between hospital and survival status. So we want to see, does it make a difference which hospital you go to? So we want to see if you go to hospital A or if you go to hospital B, does it make a difference which of the two hospitals you go to on whether you'll survive or not survive? But we're doing it for them surviving, so it should be fun.
These numbers are a little too familiar.
What do you mean? Like we did the
Like,
problem before?
no, like it's been happening too much in the real world.
Oh, with the coronavirus?
Yeah.
Here, well, we'll stay on the happy side. We'll focus on people who survive. So we'll say they went to hospital A and they survived. And we'll also say they survived. They went to hospital B. So let's do this one. So for this first one, what is the given? So what is the information I already know? Do I already know they survived? Or do I know that they went to hospital A? And just remember, whatever come after the vertical line, that's the given.
So they went to hospital A and we're trying to find out if they survived or not.
Yeah. So pretty much we already know they went to hospital A. So I'm just going to focus on this row over here. So in that row, how many of those people went to hospital A?
2,100.
Yeah, 2,100. Of the 2,100, how many of them survived? Oh,
63.
so you're killing them now? Because right here they die. I don't want them to die. Don't we want them to survive?
2,037.
There you go. So we'll say 2,037, and we'll divide that by 2,100. And you get 0.97 or 97%. All right, and that's it for A. Oh, that's it for that first part. Any question how we got that first part? So if you look at 97% of those people survive. So let's do hospital B. So how many people went to hospital B?
800.
Oh, perfect. 800. So we'll put 800 here. Of those 800 that went to hospital B, how many of them survived?
784.
784. So let's calculate that. So we'll say 784 divided by 800. And you get 98%. And that's it for that second part. Any questions for that part? So right now what we're gonna do, we're gonna comment based off of the hospital. So for this one, does it look like it make a difference which hospital do you go to on whether you survive or don't survive? Or are they pretty much both the same? Cool. Yeah, so the same. So for this one, we're gonna say there no association between the survivors So for this one, we'll say there's no association between the survival status and hospital because both of the percentages are relatively the same. All right. And that's it for that problem. Any question for this last problem? All right, so let's scroll on down. All right, so let's do this next problem. So this problem had nothing to do with death, so it should be a good problem. So for this problem, what we have the ultrasound prediction, and we also have what the baby actually turned out to be. So right here, you're telling us the ultrasound predicted the baby should be female. The ultrasound predicted the baby should be male. Over here, telling us what the baby actually turned out to be. So the baby turned out to be a female or the baby turned out to be a male. So that's what those are doing. All right. Any questions so far on the two-way table? So let's do A. So for A, it says find the probability a newborn baby is female. So how many total baby actually turn out to be female? So how many female baby did we actually get?
480.
Yeah, 480. And for this one, you'll divide it by 100. Oh, sorry, by 1,000. So you get 48%. That's it for A. Any question for A? All right, let's do B. So for B, it says find the probability a newborn baby is male. So this one we want to find male. How many total male do we have?
520.
520. Same thing out of 1,000. So you get 52%. And that's it for B. Any question for B? So let's fit in C. So C is where the conditional probability come into play. So it said use the given information to estimate the probability a newborn baby is female, given that the ultrasound predicted the baby would be female. So for this one, if you look at it, they already told us one of this thing has already happened. So they already told us the ultrasound predicted the baby will be female. And the reason I know that is because it says given that. So they're giving you that information. So they're giving us the information that the ultrasound predicted the baby will be female. So what we want to do here, you're only going to focus on baby who were predicted to be female.
Hello? We've been trying to
So for this one, we're going to find probability is female, given it was predicted female. So how many baby were predicted to be female?
Is it possible for you to scroll up on your iPad? We can't see the bottom.
Oh, sorry about that.
Thank you.
So how many baby were predicted to be female? Well, if you look at what I highlighted, you want to use the bottom number. So we actually want to use this one right here. Because that's telling you there's 562. So we have a total of 562 babies that were predicted to be female. And then what we want to do, we want to divide into how many of them were actually female. So of the 500, oh, sorry, I put 526, should be 562. So of the 562 baby, how many of them actually turned out to be female? Well, it should be 432. Because if you see how many were actually female, it will be 432. So I'm gonna go ahead and calculate that. So you say 432 divided by 562. And you roughly get 0.769 or 76.9%. All right, that's your answer for C. Any question for C? So let's do D. So for D, if you read the problem, it says use the given information to estimate the probability that a newborn baby is male, given that the ultrasound predicted the baby will be male. So if you like, we have that keyword given that, and they're telling us the baby or the ultrasound predicted it should be male. So we're gonna say probability, and the given is predicted to be male. And if you look at the first thing, they want to know what the probability it actually is a male. So we want to find the probability a baby is a male, given that the ultrasound predicted that the baby should be a male. All right. Any questions so far on the notation? All right, so I'm gonna scroll up. For that, we could start getting our numbers. So for this one, we're gonna focus on ultrasound predicted male. So how many total baby were predicted to be a male? Remember, you can just put it on the chat. The total number of baby that were predicted to be male. Yeah, so you just want to use this last number. So we use 438 because that's how many total were predicted to be male. Of the 438, how many of them actually turn out to be male? Well, should be the 390. So for this one, we're going to say 390 divided by 438. So we'll see 390 divided by 438. And you get 0.89 or 89%. So you get 89%. Any question how we got the 89%? All right, so lastly, let's do part E. So for part E, so based on your answer to part C and D, do you think an ultrasound is equally reliable for predicting gender for boys and for girls? So we've seen the number. So if the ultrasound predicted it to be female, it is right 76% of the time or 77% of the time. If an ultrasound predicted it to be male, it was right 89% of the time. So is it equally reliable or is it more reliable for a certain gender?
It's more reliable for a male.
Yeah, so we'll say the ultrasound is more reliable for a, so it's more reliable for a male. So there is an association. So that is saying if you're a male, the ultrasound will make a better prediction versus if you're female, it's only gonna be right 76 or 77% of the time. Versus for a male, it's gonna be right 89% of the time. So for this problem, we'll say there is an association. Any question for this last problem? All right, sweet. So what we're gonna do, we're gonna stop it right here for that way you're not overwhelmed with this. So we'll stop.